Hey folks, welcome back to another video in this coding challenges series. Um, if you were waiting for the next PyTorch video, trust me, that's in the pipeline. I just got delayed because I had to put some final touches on it, but that will be out soon. But today we will look at more or less a slightly easy problem, and again to do with binary trees because, why not? So in the previous one, we solved binary trees using BFS, and in this one, I want to use some recursion. So let's first look at the problem. Basically, it's called binary tree right side view. Given the root of a binary tree, imagine yourself standing on the right side of it and return value of the nodes from top to bottom that you see on the right side. Okay, let's look at the example. So for this tree, we return these values 1, 3, 4. Let's look at this example. For this tree, we return 1 and 3. Okay, so it seems like this problem, it's not worded very well, but since I've seen it before and I've solved it, basically what you have to do is return the rightmost element at each level. So let me actually explain that. Let me bring my notepad window up. Okay, and let's zoom in a bit and let's create this tree. So I have a tree whose um, nodes are like this. Uh, and then I have, it really doesn't matter, but then, oh. So 6 is my root node. Let me make it a bit more easier to understand by, uh, should have done this before starting to create the video, but it's all right. We got there. Not a bad job. All right, okay. So you can see 6 is the root node, then a left child is 4, 5, 4, and then I have a 5, and a 3, and a 5, and a 7. So in this case, the correct value would be 6, 5, 3, 7. So we are only returning the rightmost elements or nodes at each level. All right. So 6 here is the rightmost, 5 is the rightmost here, 3 is the rightmost here, 7 is the rightmost here. So pretty straightforward. At least it feels pretty straightforward. Um, oh shit! I accidentally removed the capture that I wanted to keep. Okay, give me one sec while I get back my window. All right. Pains of, OBS. I like OBS. It's a pretty cool tool. All right, so basically we will be given this tree and we will return a list of all the rightmost elements. Okay, now let me reframe it in a way that makes sense. Okay, all right. And again, just like last time, I will code it out in both Python and C++. And I will be using recursion. So let's dig in. So first, let me type out the solution, and then let me walk you through it. And I always find it easier to type in Python first. So let's say I have the list that contains the rightmost elements. So I'll call it right elements begins empty. And then I pass in to a helper function well, I'll choose 3 arguments, the node, this list, and the level. And then basically I need to return this. Now let's create this this worker. which takes in all these. Okay, so first let's put the first condition that if I encounter null, just bail out. So just return. Now, now comes the interesting condition. Now, if length of elements, oh, I should keep this as level. If length of elements is equal to level, then basically I need to push back. So no, the current val. And then I will first check the right branch and then the left branch. I understand this might be a bit confusing right now, but let me type it out and then I'll explain what I'm trying to do. Level +1, and then the same thing for the left branch. All right, I think that's pretty much it. Now, let's see. Okay, I have space. So let me try to explain what the code is trying to do with the same example what we did before. So we had, let's say, oh, this is going to take a while, so just bear with me. 4, and let's say I have a 5, and then I have, I'll just make 1, 2, and a 3, and then I'll just add 2 here, 7, 8. Okay, so first, okay, so there are 2 functions. What this getRight does, it takes in 3 arguments, and the arguments are basically the root or the node you are at. Well, root is, so I should make it node. Node. It's more explanatory. Node. All right, so the first time when I start my search, here I pass in the root, which is 6. All right, so give me one. Right, so the first time root is called, so well, getRight is called with 6 being the node, and then the elements are empty and the level is 0. So the condition none is not satisfied. We see that the length of, so the level is 0 and the length is 0. So it appends 6 to my list. So my list gets appended by 6. And then first, always I call the right element first and then the left element. Because we are focusing on the right ones, that's why we call the right ones first. So then get right of 5 is called. And what's here? There is 6. And then level is appended by 1, so I get level 1. And then, so this calls this one. And then, okay, so we will go into this stack first. This is called later, so we won't get into that yet right now. Let's first just go all the way down. So now we are at 5. Now at 5, again, the length is 1 and the level is also 1. So 5 also gets appended and we again go to the right element. So from here we call get right. Now, what is to the right of 5? There is nothing, right? So I get a null, and then this is 6 and a 5, and then my level is 2. Now, because it's a null, this condition is triggered and I return out. So now I go back to the previous node 5, and then now I go to the left leg, this condition. And then when I go to the left one, I basically get a 3. Now 3 again satisfies this condition because the length is 2 and we are at level 2. So 3 gets appended. And then for 3, we again go to the right node um, and then we enter 8. So then I get right 8, 6, 5, 3, and then we're at level 3. Now 8 again satisfies this criteria. So 8 gets appended, and then we probe the two children of 8, right and left, which are both null, so we return out. We go back to, we backtrack back to the node 3, and then we enter the left node. So we now enter the left node. And notice the level was again 3. So now this condition is not satisfied because the length is 4 and the level is 3. So we don't do any appending, and we again check its children, and then again they're null, so we bail out. We go back to the node 3. Um, the search for 3 has ended because we've checked both its left and right. We go back to 5. Its search has ended because we've searched for both its left and right. We go back to 6, and then we go back to 6's left. So for 6's left, we enter 4, but this list has already been populated with all the elements. So again, the if condition is not satisfied. So this is not satisfied. So we go down, and then none of those ifs are satisfied, and then we just bail out, and then we return this list. So I hope my explanation made some sense, but this is the way we are backtracking and using recursion to get all the right elements. All right, so let us run it. Good. Let me submit it. Let's see. All right, great. So pretty awesome memory usage. It's like bad runtime, but it's all right. Let's code the same thing in C++. So um, I'll again, whatever I coded in Python, I'll just do the same thing, exact same thing in C++. So let's go to C++, and let me again create a get right function, which is going to take in the node, specifically the node pointer, a vector of values, so which is right list, and I want it to be taken as reference because this is the list we are modifying, and a level. So first check if node is a null pointer, then just return. Yeah, so that's that. Now if the right list dot size equal the same check that we did for the size equals level, then basically we push back into my list. And what do we push back? We push back the node val. Since it's a pointer, we need to do the arrow thing. All right, that's that. Now we just call get right again with node right first, right list, and then level +1. And then we do the same thing for left. Good. So here, the first thing I want to do is I want to create a vector of int called right list, and then basically that's the thing that I'm going to return. And also let me call the function for the first time with the node or with the root. Okay, this seems good. Let's see if there are any errors. Okay. Oh, silly typos. Notice that we only had to use just one thing, vector, because this was a pretty straightforward problem. Interesting. I get the wrong answer. Right. So I am, let's see, is there anything different that has happened here? Yeah, part of the whole point is to, debug issues. So I am getting a 134. I should get a 134 and I get a 12. So let's debug this. I'm just making it a bit more verbose. Oh, I see. Yeah, it's the post increment and pre increment issue. Yeah, so if I did a plus plus or a plus plus level, then the value of level gets changed, and then that would get changed on the next call as well. So it's so you have to use the same value of level plus one, because that's what we want to supply. We want to supply the same value of level to both the function calls, and that's why that was the issue. Oh, pretty minor. Well, yeah. All right, let's submit it and see how well we did. Whoa, that is the fastest. So I don't know if you can see, it's faster than all the C++ submissions. That's pretty awesome. It's a bug because they don't have the granularity to capture the latency that we had. But good job, good job. Even good memory usage. So that's pretty much it. We can actually increase the runtime by pre-allocating the by pre-allocating my vector, because then it wouldn't have to increase size when I do pushbacks. But again, that's some advanced stuff. Um, that's pretty much it. So this was a pretty simple and easy problem to solve. And yeah, let me know if you have any questions, and I will see you guys again in the next video. Hopefully the PyTorch one is coming soon. So see you guys.